All right, here are solutions for perfect problem 1 for Math 251. We're asked to evaluate 3 limits without the help of a calculator. Okay. Well, for this first one, your inclination might be, it would be nice if I could change all my x's into 3's and just figure out what this thing is equal to. Kind of find, if you think about this as a function, evaluate that function at 3. Unfortunately, if you do that, you'll get 0 over 0. So really what we have to do is change this. Instead of looking at the limit as x approaches 3 of this function, we'll look at the limit as x approaches 3 of a different function, a function that's the exact same as this function in all spots except for one spot. What I'm trying to say is if you factor this thing out, I can rewrite this expression as just x minus 3 times x plus 2 divided by x minus 3. And limits have this nice property that this limit is exactly equal to this limit right here. You kind of cancel out this x minus 3 here and here. You have to be careful. You can't just cancel these out and say that this is the same as this, because it's not. This right here is not the same as this right here. They're the same everywhere except for when x equals 3. When x equals 3, this thing right here is undefined because it's 0 divided by 0. But when x equals 3, this thing here is defined. So this is different than this. So it's weird that I can put an equal sign here. But I can do it because the limit of this is the same as the limit of this. Because this is the same as this everywhere except for at that one point. And the limit as x approaches 3 is independent of the value of this expression at x equals 3. In other words, this line equals this line. This is easy to figure out. The limit as x approaches 3 of x plus 2. I can just change the x into a 3 and get 5. So my answer is 5. And really, as long as you get the answer, I guess I'm pretty happy. But I kind of wanted to stress why this works. And really the key to this entire thing working is not that this, what I'm circling right here, is the same as this, because it's not. But the limit of this is the same as the limit of this. Because these are the same everywhere except for at one point. And that one point being different doesn't screw up our limits, I guess is the way you can think about it. Let's do that again. Trick will be very similar. Now we want the limit as x approaches 2 of 1 over x minus 1/2 divided by x minus 2. It'd be nice if I could just change all my x's into 2's, but I can't. Try doing that, you'll get 0 divided by 0. What that's saying is this expression has a hole when x equals 2. So what I want to do is remove that hole, kind of like I did from this step to this step, which will change the value of this expression, but it won't change the value of the limit of this expression. The way you do that is you kind of want to simplify. Basically, you want to cancel out this x minus 2 right here. It's hard to see where the x minus 2 is up in the top, but we can kind of create an x minus 2 if changing this from being one, I don't know, the difference of two fractions, I guess is how you could think of them. They're actually rational expressions, but I'll call them fractions. Instead of having two of them here, one minus another one, make it just one. What I'm saying is put these two terms up in the numerator here together. Multiply this by 2 over 2. So I get 2 divided by 2x. Rewrite my limit here. And multiply this by x over x. And I get x over 2x. And the reason you want to do that is because now we have a common denominator here. So I can say this is the limit as x approaches 2 of 2 minus x divided by 2x, all divided by x minus 2. You still might not be able to see how you can cancel out this x minus 2. Turns out you'll cancel it out with part of this 2 minus x here. I think the easiest way to see it is to change this so we don't have this fraction inside a fraction business. And the way you can do that is if you view this x over 2, x minus 2 as x minus 2 over 1, I can say this is the limit as x approaches 2 of 2 minus x over 2x times 1 over x minus 2. Going from this step to this step, I took advantage of the fact that anytime you're dividing fractions, really all you're doing is multiplying the fractions, except you're multiplying by the reciprocal of the denominator. Easier way to say it is if you're dividing fractions, take the one on the bottom, flip it upside down, change it into multiplication. I guess me here. Remember, my goal was to get rid of this x minus 2, which is now right here. It's this that I want to cancel out, kind of like I wanted to cancel out this x minus 3 here. The way I'll do it is by noting that 2 minus x, we'll write it out in one more line. 2 minus x is the same as negative 1 times x minus 2. It's a little trick that can come in helpful when you're trying to algebraically manipulate stuff. That kind of, when you're subtracting, if you want to switch the order, pull out a negative 1. If it's hard for you to see why this is the same as this, take this negative 1 and distribute it back in. You'd get negative x plus 2, which is the same as 2 minus x. The advantage to this form over this form is what I can now do is kind of cancel out these x minus 2's. I say kind of do it because you can't just cancel out these x minus 2's. This entire thing that I'm circling is not the same as negative 1 over 2x, what I'd have left if I canceled out these two. It's not. However, the limit as x approaches 2 of this thing is the same as the limit as x approaches 2 of this thing. The limit as x approaches 2 of this thing is something I can figure out. I can just change all my x's into 2's and get negative 1/4. So again, the little trick I did, which a lot of people don't even notice that you're doing, is I canceled out this x minus 2 and this x minus 2, which people are like, yeah, just cancel it out. But you can't just cancel it out unless you have these limits written here. This is only equal to this when you have limit written out in front of it. Anyways, that's what you do for part C, or for part B. Now I'll do part C, and then that'll be the end of this problem. I want to figure out the limit as h approaches 0 of the square root of 81 plus h minus 9 divided by h. Same problem I've ran into a few times. If you change all the h's into zeros, kind of try to evaluate this limit, hoping that it's continuous, you'll get 0 divided by 0. This would be 81 plus 0 is 81. Square root of that is 9. 9 minus 9 is 0, divided by 0. So really, it's this h on the bottom that's causing trouble. I want to be able to cancel out this h on the bottom. The way you do that is with a little trick. You say that this limit is the same as the limit as h approaches 0 of the square root of 81 plus h minus 9 over h times the square root of 81 plus h plus 9 over the square root of 81 plus h plus 9. What I'm saying is multiply the numerator and the denominator by the conjugate of the numerator. Take this exact same thing that we have written here, except change this minus sign into a plus sign. And you can do that because we have these limits out in front. That doesn't change the value, even though we're adding this variable in here. This doesn't change the value of anything. But when you FOIL everything out here, what you'll see is things will cancel out nicely. Maybe I should just do it and it'll make more sense. If you think about this like foiling, like this is a binomial. Here's the first term, everything here, and here's the second term. And here's the first term, and here's the second term. If I'm going to FOIL it out, I'm going to multiply this times this. The square root of 81 plus h times the square root of 81 plus h is just 81 plus h. All right, that's the square root of 81 plus h squared. The squared and the square root cancel out. And then I take this term, the negative 9, and multiply it by the square root of 81 plus h. And so I get negative 9 square root 81 plus h. And then I take this positive 9 and multiply it by this square root of 81 plus h. And then finally the negative 9 times the positive 9 gives me minus 81. And that entire mess, which will actually simplify quite nicely, gets divided by, on the bottom I have h times all this stuff. If you really wanted to, you could distribute, but it'll turn out that we're going to cancel things out, so it's easier to not distribute, easier to leave it like this. What I want you to notice is we have negative 9 of these things and positive 9 of these things, that this and this cancel out. Also, I have 81 and negative 81, those cancel out. All that I'm left with is h divided by h times square root of 81 plus h plus 9. I can now cancel out these h's. Got to be careful. You can't just cancel out a variable. This, what I have written in this fraction, is not the same as 1 divided by the square root of 81 plus h plus 9. This fraction is not the same as this. However, the limit as h approaches 0 of this thing is the same as the limit as h approaches 0 of this thing. So because I have those limits in there, I can make the step from here to here. And that's key because this is a limit I can evaluate. I can evaluate this just by changing all the h's into zeros. I get this is 1 divided by the square root of 81 plus 0 plus 9. In other words, 1 divided by 9 plus 9. In other words, 1 divided by 18. That looks ugly. Let me try to rewrite that, which is the final answer. Maybe I should box up my answers. Final answer to part C, which is the end of this kind of difficult series of examples.